All right, final video for this section. We're going to talk about piecewise functions here, okay? So, quick introduction on what piecewise functions are. All piecewise functions are functions that have different pieces, okay? So, for example, we have a graph right here of some cost function, and there's some rule that defines this linear relationship for the cost function up until a certain point. But then if, n is bigger than or equal to 10, we have a different rule that determines it, okay? So we have sort of a line here and a different kind of line here, and we just piece them together, okay? That's sort of what we're looking at with the piecewise function. So I'm going to show you how to evaluate piecewise functions and then how to graph piecewise functions, okay? So let's start this off right here. Example, my numbers are all messed up. We're going to go into letters. We're going to say example A because consistency is already gone in this section anyway. Okay, so evaluate the following given this function. So we have f of x, and here's how piecewise functions are defined. We use a giant brace, and then there's different pieces. So here, our first piece is going to be the function is just x squared, a parabola. The second piece is going to be the constant function 3. The third piece is going to be the identity function x. And the important thing here is just when do we use each piece? So if your input is less than or equal to 1, we're going to use that first piece. If your input is between 1 and 2, we're going to use that second piece. And if your input is bigger than 2, we're going to use that third piece. So I'm going to show you exactly how this all works. And again, the book has some good descriptions on this if you're feeling uncomfortable with piecewise functions, you want to see it more. So example A, part A, find out what f of -4 is. So you have to figure out what's our input, right? So our input here is -4. That's our input. So how do we know which piece to use? We need to figure out what condition does x equal -4 satisfy? Right? This is our x. So -4, is that less than or equal to 1? It is. -4 is not between 1 and 2, and -4 is certainly not bigger than 2. -4 is less than or equal to 1, right? -4 is less than or equal to 1. So let's name these, right? Name this the first piece, second piece, the third piece. Use first piece. So f of -4 is going to be, this is the rule that we have to use here, -4 squared, which is 16. All right, and that's the basics of evaluating piecewise function. You just have to figure out where is your input, determine which piece you're using. Do another one, part B. F of 1. So our input is x equals 1. We have to figure out which inequality does this fit in? Which piece are we at right here? And it's going to be the same one here, because 1 is less than or equal to 1. 1 is not between 1 and 2, and 1 is not greater than 2. So again, use the first piece, and we're going to get that it's 1 squared, which is just 1. Let's do some more. Part C. F of +3. Is +3 less than or equal to 1? No, +3 is bigger than 1. Is +3 between 1 and 2? No, not between 1 and 2. Is 3 bigger than 2? Yes, 3 is bigger than 2. Use part 3 and says that f of 3 is equal to x, which is 3. All right, that's the rule that we use here. Do another one. Part D. All right, I can barely fit function and D on the same one. Part D is going to be f of -3. So again, -3, that's a number that's smaller than 1. Our x here is smaller than 1. So we use this piece. Again, we have negative 3 squared. Using that piece a lot. Positive 9. Part E. Let's do some more of these. F of 2. Which piece is 2 in? 2, our x value is 2. 2 is not smaller than 1. But 2 is between 1 and 2, since it's inclusive here. So we use that piece. This says our function is just 3. That's our value for E. Keep going. Part F. Okay, F of 4. Again, our input value is x. X is bigger than 2. 4 is bigger than 2. 4 does not satisfy either of these other inequalities. 4 only satisfies this inequality, which tells us we need to use this piece. So f of 4 is equal to x. Well, what is x? X is 4. F of 4 is 4. One more. F of 0. And again, 0 is less than or equal to 1, so we get 0 squared is 0. So that's sort of how we evaluate piecewise functions. Graphing them is more exciting. Okay? Again, if you have more questions on evaluating these, the book has some good resources, and you can also contact me on Slack or email. Okay? So, oh dang it. I really need to, I don't want to have to be flipping back and forth, so I'm going to use a fresh page. Again, hello, Miss Doctor in the pandemic. Here we go. Example B, I guess. Again, our numbering is crazy. Graph the function from example A. Okay. So we're in luck, right? Because we just found a bunch of function values, right? Let's make a table with these. Okay. We already have values. I'm just going to copy this down real quick, just from the previous example. Right? We said when x was negative 4, we said y was 16. We said when x was negative 3, y was 9. Again, we already did this. I'm not making this up. When x is negative 4, y was 16. When x was negative 3, y was 9. So we're just going to copy this down some more. What else did we have? We had, did we have a negative 2? No. Did we have a negative 1? No. Did we have a 0? Yep. When x was 0, we had that y was 0. When x was 1, we had that y was 1. When x was 2, we had y was 3. And when x was 3, we had that we were at 3 as well. Okay. And we also had when x was 4, we were at 4. So we already have a bunch of x coordinates. Let's start with that. Okay, a bunch of x and y coordinates. So we have our graph here. Again, graphing paper is helpful, but not mandatory. So I will not be actually using it for the notes, just to show you what you would do if you didn't have it. I like to make my 5th hash mark a little bit bigger, easier to read. Plot these. Negative 4, 16. Somewhere up here. All right, negative 3, 9. We can do that. 6, 7, 8, 9. Negative 3, comma 9. You can plot that. 0, comma 0. You can plot that. 1, comma 1. 2, comma 3. 3, comma 3. 4, comma 4. And you say, great. That's a great start, Jason. I know exactly what the function is going to look like now. Don't you guys? So that's a start, right? You can plug in points, and that is a start. But really, we just kind of have to look at this piece by piece. Okay? Our first piece should be a parabola. Our second piece should be a constant function. Our third piece should be that identity function. Should be a straight line. So let's graph each piece by itself. For everything less than or equal to 1, we have a parabola. So from here to the left, it should look like a parabola. So what do we know about parabolas, right? I have some parabolic function, 1, 1, we already have that. 0, 0, we already have that. And x is negative 1. Negative 1 squared is positive 1. We can add that. When x is negative 2, we're looking at this piece, only looking at a little piece right now. And we know that everything to the left of this point is going to be that piece. Negative 2 squared is positive 4. We can graph that. And now we can really see that parabola. And remember that the parabola is only to the left of 1. We start at 1, and we can graph that parabola. So we have graphed the first piece. Don't graph it to the right, because to the right of 1, right, to the right of 1, we don't have a parabola. The parabola is only if x is less than or equal to 1. Now we have a constant function when x is between 1 and 2. It's always going to be 3 if x is anything bigger than 1. As soon as you see this strictly less than sign, that means an open circle. 1 is not included in this constant function. So everything between 1 and 2, closed circle at 2, open circle at 1, is going to be that constant function. So it's always going to be 3. There's an open circle. When x is 1, that's when we start this piece. And it continues all the way until x is equal to 2. It's that constant function between 1 and 2. That constant function value is 3. Graphing this is probably going to be the hardest part of the section for many people. Okay. And now we just have the last piece. What is that last piece? It says x is bigger than 2. We use x. So our last piece is going to be some other function. But this is only when x is bigger than 2. So again, strictly bigger than means an open circle. Where's the open circle going to be? Right? H of 2 is just 2, identity function. What you put in is what you get out. This is where the open circle is. The open circle is always when there's that less greater than sign. Here, that's where we had the open circle from the previous point. When x is 2, we're going to have an open circle at positive 2. When x is 2, we're going to have an open circle when y is positive 2. And now we already have that when x is 3, we're at 3. When x is at 4, we're at 4. We have the identity function. We could get more points, right? When x is 5, the identity function says we should be at 5. We found the open circle. We know that this is what the identity function looks like. That's how we can graph that third piece. So again, once you just graph a bunch of points, you should be able to just work on each piece at a time. The hardest part for these is identifying where these open circles are. Okay? But watch out for that. All right. This was actually where I was going to end the video. But in the event that people want to watch another example, I'll record another example for you. I have time to go through it quickly, and then I have to teach another class, okay? Because again, it's snow day today as I'm recording these, and I have a Zoom class very soon. Okay, so I'm going to go through another example really quickly. All right, and let's try it number 8 from the book. So graph f of x is equal to x cubed, negative 2, and the square root of x. Again, 3 pieces. Let's say if this is x is less than negative 1, negative 1 is less than x, which is less than 4. And when x is greater than 4 is our third piece. Okay, 3 pieces just like last time. We're going to make a table just like last time. Table of x's and y's. And a graph that we're going to plot this on. Okay. Again, going to have that big hash mark at 5. So the first piece is going to be a cubic. Remember what a cubic looks like? It looks kind of like this. That's going to be the first piece. Less than sign, open circle here. So right off the bat, this is where we're going to have an open circle right here. Okay, because at -1, I shouldn't actually have written -1 here. -1, we're actually on the second piece. Okay. But I don't know, maybe let's call this first piece F1 maybe, F1 of X. Where's the open circle? Open circle, right, is when X equals 1 for that piece. So on that first piece, 1 cubed. That's just 1. So now there's going to be an open circle at 1, 1. And everything to the left of here is going to be that cubic function. So when X is 0, oh, -1, oops. Dang it, I misread the function. So -1 cubed will be -1. This is where the open circle is. And crap, there's nothing here. Ignore that. The pen strikes again. This is what I get for rushing. Okay. So to the left of -1, to the left of this open circle, we're on that cubic function. So -2. -2 cubed is -8. Oh my word, this grows very quickly. 6, 7, 8. And remember, it follows this shape. On that left piece, really going to look kind of like this. Now we can't plot really any more good points. You could plot fractional points if you wanted. So let's look at that middle piece. I wrote the problem down wrong. Here we go. Look at the middle piece. All right. The middle piece starts when X is -1 and goes until when X is 4. Oh, open circle. I know there's going to be an open circle here because it's less than 4. The function doesn't use this piece at 4. Well, let's look at that. All right. The second piece is always equal to -2, and there's going to be an open circle right here at X equals 4. Go over here at 4. It's a constant function. It's -2. Open circle when X is 4. Y is -2. We know there's an open circle here. And let's keep on filling in points. -1, that's when we start to be on this piece. Well, it's a constant function. -1, -2, right here. 0, also in this piece. It's a constant function, still -2. In fact, it's going to be a constant function for this whole piece. This whole piece is just going to be that flat line connecting right here. Now we move on to the last piece, which again, I have to go quickly. The last piece starts when X is 4. Square root of 4 is 2. We have the point 4, 2. Square root of 5. You could use the calculator to get an approximation. Or you could just jump up to a nice number. Square root of 9 is 3. We have a point 9, 3. And again, remember that a square root function, these toolkit functions are coming back, looks like this. So the square root function would go like this, but it only starts here. Kind of grows here in a weird curvy way. This is not a line. This is y. Just a little sketch like so. All right. That's what we've got here. And we have a beautiful graph. All right. Please reach out if you have more questions. Okay. And we'll talk about piecewise functions some more via Slack or email. All right. Have a good one.